Hello everyone. In this project we want to control the DC motor and able to control its rotation and also turn that clockwise and also counterclockwise. So let's see what we need for this project. So as you could see, we have our DC motor, we have our H bridge, which is the board that we use is L298N, which is a H bridge. So we have one switch, we have one variable resistor, and we have our launchpad, which is actually has the Cortex M4 microcontroller. So whenever you start your microcontroller, turn on your microcontroller, you're able to control the speed with this variable resistor that you have. So as you could see, I'm actually increase this. It's actually able to increase its speed and rotation. So also you could decrease the speed of your DC motor. So even you could stop that. So that means with this variable resistor, you are able to control the speed. So right now it's actually turn counterclockwise. So we have one key here, one switch, which is able to somehow change the direction of rotation. So right now it's actually turn counterclockwise. Whenever you push this switch, it's able to rotate in the opposite direction. Right now it's turning on the clockwise, and still with this variable resistor, you are able to control the speed of the DC motor. So again, so with pushing this switch, you are able to change the rotation direction. So see, whenever I'm pushing this, it's actually turn in or rotate in the different direction. So, and in the same time, you could control the speed in any direction that you want. So as you could see, while I'm pushing the switch, and it's able to turn in opposite direction. So let's take a look to the circuit diagram and also the codes and see how we could do this project. So this is the circuit diagram. So as you could see here, this is our TIVA C series launchpad. This is our L298N, which is our H bridge, and this is our DC motor. Here we have the variable resistor. This is our key. This is the 10K resistor that we use to keep these 0.0, and this is the whole things that we have. This is actually is your power supply. Here we use a 10 volt external power supply for somehow driving this DC motor that we have. So start with these pins that we connected to the 12 volt. If you check your L298, usually there is a 3 ports. So middle one is the ground, on the right side is 5 volt, other one is 12 volt. So we actually connect that 12 volt pins to the 10 volt DC power source. You could even have 12 volt, but we use actually 10 volt external power supply. So we don't use the 5 volt that we have here on the L298N, and don't forget to connect the ground to your external source ground that you see here. We actually did with this wire. So then back to the other pins that we have. Let's start with the enable A pins that you have on L298N. So this is the pins that you could enable your DC motor that you are connected to output 1 and 2. So and also you could connect pulse with modulation signal. So this is what we did. We connect our pulse with modulation signal to port PF1, and we send pulse with modulation signals through these PF1 port to enable A. So we have two other pins, which is IN1 and IN2 on L298N, which is they are somehow our inputs which control the DC motor direction. So which is, it could be the forward or backward. So whenever input is high, INT2 is low, it's actually turn forward, and whenever this is 0, input 1 is 0, and input 2 is high, so it's actually turn reverse. So that's what we here, we connect the input 1 to the, if you check this, input 1 connected to the PD1, and INT2 here connected to PD2. So again, if you follow IN1, so it's connected to the PD1, and the second input is connected through this wire to PD2. So the output 1 and 2 connected to the DC motor. So that's what you see here. So don't forget to connect the whole grounds together. The ground of these L290N connected to the ground of the LaunchPAD, and it's connected to the ground of the external power source that we have. So take a look to the switch. So we have one switch. We put 10K between 10K and the ground. Here is ground, and it's connected through the 10K to one side of the switch. So the other side of the switch is connected to the 3.3 volt, the VCC that we have on the LaunchPAD. So this is the 3.3 volt that we have on the LaunchPAD will be connected to the other side of the switch. So these points should be connected to one IO. So if you follow this, it's actually connected to PD3. So that means PD3 is the port that somehow get the information of the switch and know it is 0 and 1, and based off that it's actually turn the direction of the DC motor. And finally, we have the variable resistor. One side goes to the 3.3, another side goes to the ground, and these mid pins goes to the PD0 in your LaunchPAD. So this shows the all connection that we have. So let's take a look to the codes and see how codes works. So this is our code. So here we define some names to the port IO ports that we use. So the PF1 that I already mentioned on the circuit diagram is enable A, PD1 is input 1, PD2 is input 2, and PD3 is the button that we use. So we actually declare one variables. We name that pressed. So in the beginning we initialize that with the false. You will see how we could use that. So in the setup, you just tell enable A, which is the PF1, input 1, which is PD1, and PD2, which is input 2. Definitely they all should be the output, and the bottom should be input. So then we actually write in the input 1 and input 2 somehow low, and in input 2 high. So because you put these here, so that means default direction of your motor should be input whenever input 1 is 0 and this is high, so it is counterclockwise or reverse. So that means somehow here you are telling the whenever you push the reset button of the microcontroller based off these initial value that you have, it actually turn counterclockwise. So back to the main loop. So you use analog read, which is somehow read the variable resistor that we have. We connect that to the PD0. It's actually read that value. So the analog digital converter in the LaunchPAD is 12 bits analog to digital converter. So that means whatever you got here in PD0, the value should be between 0 and 2 power 12, which is 4096. So, but what you need here in the analog write for the pulse width modulation, it is just change between 0 to 255. So that's the reason we actually use the map function here. So whatever you got through these analog to digital converter, which is between 0 and 4096, somehow it's mapped to this range, which is 0 to 255. You save that to inside the variable pulse width modulation. So then you use the analog write, which is somehow you sending the pulse width modulation signals to the enable A port, and you are able to control with these value that you see. So that means these PWM variables, you are able to change duty cycle. So then you have few if statements. So these two lines somehow take care of the debouncing of the switch. So as you could see, whenever you push or release the switch, it's for a short time somehow it's bouncing. It's actually changed the value too many times between 0 and 1. So these two lines somehow take care of that bouncing switch. So you actually read the switch that you have, if is that true. So that means if you push the switch, you change that the variable of the press. If we already initialize that to the false, so that means it should be changed to the not of that variable, which is, if this is false, it should be true. If that's true, should be false. So there is a reason for that, because whenever you push the switch, somehow you want to change the direction, right? So that means if that's true, you change that the false and you go to the other sections that you made here for false. And if it's true, again, it's change that. So that means you run other few lines that you put in the if statement. Somehow, definitely whenever you push the switch, you actually run the different if statement body. So one actually turn that clockwise, the other one actually turn on the counterclockwise. So that means with this line, definitely you are telling whatever you are right now you are doing, you do the opposite of that because of these not that you have. If you are on the clockwise, so that means this time you run the body of counterclockwise. If you are in the counterclockwise, whatever you are going to run, you run the clockwise, actually, the codes. So that's what you did this. So then you actually, here is the while loop, which is whenever it is true, it just wait 20 millisecond just because you want to somehow fix the bouncing issue of the switch. So as I already mentioned, definitely you expect to have two if statement, and inside their body, one should be turn the DC motor on the clockwise, the other one should be counterclockwise. So whenever these pressed is true, so the only difference is the value that you put inside the input 1 and 2, right? So whenever this is true, input 1 high and input 2 low means actually forward, moving forward, or clockwise. And the next one is opposite of that. It is input 1 is low and high for input 2 means reverse, so or counterclockwise. So that means if this is true, it goes to this direction. If it's false, it's actually do the opposite of that. Whenever you push this switch, definitely you take a knot. So that means definitely whenever you push the switch, it's actually do one of them and the exactly the opposite of the current state that you have. So this is how the code actually works. So let's upload these to the microcontroller and see if it works or not. So we upload the code. So let's see if it works or not. So I'm actually turn on the microcontroller. So as you see right now, it's turning on counterclockwise. So with this variable resistor, you are able to change the speed in this direction. So you see you could go to the maximum speed, and even you could actually stop the rotation. So let's check our switch and see it's able to turn the DC motor in the opposite direction. So as you could see right now, it's able to turn that to the other direction, which is the clockwise. And still, whenever you change this potentiometer, you are able to control the speed in this direction. So let's do that one more time. So see, whenever I push that any times, I'm able to turn the or change the direction, and also in the anytime I'm able to change the speed with changing these variable resistor. So I hope you like this video. Thank you for watching.